So dear participants, let's move to experiment number 2 of section 1 IAVOC 305, that are experiments with embedded systems, Arduino UNO. And in this particular experiment, we will be starting with the very basic blinking of an LED. That is the first part of the experiment. Then we have to control the brightness of LED using PWM function. And finally, we will be blinking the LED, or we can make the LED on or off with the help of a momentary push button switch. So I have given the codes in the manual, as well as we will be discussing the sketches during the operation. And I would like to mention one thing, that there might be some deviations because of non-availability of components in some cases, or in order to show the variety of or the multifacetedness of the program, we have made some changes during the operation. So that can be easily understood, and that you have to consider during development of your own codes. And definitely in each case I will be suggesting some assignments that you should try to perform, which will give you better idea of operation with this very versatile platform of Arduino IDE. Now, what are the equipments that will be required? Definitely we need one desktop or laptop, that is the programming terminal. Then we need the UNO board, USB cable, plug A to plug B type, that we have already seen on experiment 1. We need an LED. We will be using a 5 mm LED here, a 330 ohm resistor which will be acting as current limiting resistor to the LED. Then we will need an 10 kilo ohm resistor that will be required for pulling down one of the switch terminals to ground. Then we will be using a push to on momentary switch, but in this case I couldn't find a push to on momentary switch right now with me, that's why I have used a press type switch. And finally some male to male jumper wires will be required. Let us see the components. You can see here that this is the Arduino board that we'll be using. We need not to be very worried with this thing. This is simply a shield that I can connect with this Arduino. This is the same Arduino UNO that we all have very familiar with, and on that I can connect this screw shield. Okay, these are the box strip connectors that can be very easily inserted onto the female terminals of the Arduino board, and we can connect it. Now the facility of this board is, you can have the reset pin here. You can see this is the reset pin. You can reset the board, and you have got screw terminals. Many times what happens, that what I have seen during several demonstration sessions, that during this movement of my fingers, some of the jumpers, they may get out of these terminals. Therefore I have preferred over this switch, this screw terminals. That is not at all mandatory or required if you want to develop your own circuits. Now see, we will be first working on the circuit that is meant for blinking the LED. Let us try to go for that. This is a very simple circuit in which you can see the cathode of the LED is connected to ground, and anode of the LED is connected to one of the digital pins. Now here we have used digital pin number 9. Okay, and while connecting the anode, be very careful that you need to use the current limiting resistance, that is the 330 ohm resistance in this case. So why this current limiting resistance is required? Because if you allow to flow excessive current, that when the Arduino pin is high, the current that it supplies might damage the LED. So therefore we will be using this series resistance. Now let us build up the circuit. It is very simple. Let us take the LED first. While using the LED, be very careful while deciding your anode and cathode, because anode and cathode you cannot decide. Okay, just a joking part, but you can see that this is something that I have done in order to have easiness in connection with the breadboard. Okay, normally LEDs do not come like this. You can see here, I will show you one LED. Now you can see this LED, this is directly from market. You can find these are the two terminals. One of the terminal is having a length which is greater and the other terminal is a bit short. You can see this terminal is short. Now the short terminal is always the cathode. Now in case if both of the terminals are cut at length, then kindly find out this notch. You can find a notch here. You can find a notch here. Here, that's a flat surface. Not but a flat surface, flattened. Entire of the surface is round. There is a flattened surface, which shows that this is the cathode of the LED. So let us try to build the circuit. So while building the circuits initially with breadboard, we normally commit one mistake. We connect LED like this. On the same line, you can see this is the same vertical line on which we try to connect the LED. Remember that this is just equivalent to shorting the pins. This is just equivalent to shorting of the pins. So don't do this. Connect the LED like this or like this. You can connect the LED like this or you can connect the LED like this. So there are different points to which you are connecting the LED. So we are making it like this. Alright. So now we will simply connect the ground to the cathode. This is the cathode that I will be connecting to ground. This is my ground terminal. I have connected it to the ground terminal. Then I will be using the 330 ohm resistance here. You can see that I have connected the terminal of the resistance to the same vertical line on which the anode is connected. Alright. Okay. Now we have to connect digital pin number 9. So I will use another terminal of the resistance and I will connect it to digital pin number 9. You can see this is digital pin number 9. This is digital pin number 9. I'll be connecting to. Okay, let us loosen the screw and let's connect to digital pin number 9. Okay. Oh. All right. Fine. That's your circuit is ready. That's a very pretty simple circuit. And we will now open the sketch. So here, this is the sketch to blink the LED. You can see initially we have declared the pin number that is connected to the LED pin number 9. We have named the pin LED pin. Then we have gone for the setup which will run only once when the Arduino will be powered. Here we have declared the pin mode. Alright, this pin mode function has been taken and we have declared LED pin as output pin. Okay, now you see here this LED pin is just a name. You can give any name to this. Okay, but in order to make it somewhat meaningful so that we can understand, we have made it LED pin. So this is the pin mode function. We have used that. We have used this LED pin as output and then we have come to the void loop section that will be continuously cycling when your Arduino will be under execution cycle. Now you see here that initially we have go for the digital write operation. So we have written high to the LED pin. Then we have kept a delay so that this high state is retained for some time. Then we have written low to the LED pin. This is digital write function used in both the cases digital write function. Using the digital write function, we have written this low to LED pin. Again, we have given a delay of 1 second. This 1000 millisecond is nothing but 1 second, and 1000 means 1000 millisecond that we have already studied in our theory part. So what do you have to do? What we can expect out of this sketch, that the LED will be blinking. It will go on, it will stand for 1 second, then it will go off, it will stand for another 1 second. Right. So we will verify the program. And we will upload the program. Initially, you can definitely ensure using the tools that your Arduino board is always there and it is connected to COM port 3. And now we will upload using the upload button. And let us now focus on the operation. You can see the LED is blinking. So that's it. This is very simple. And here I will be giving one assignment to you, that you kindly try to change the delay and see what happens to the blinking rate of the LED. You can have a good control over the blinking rate of the LED in that manner. Now let us try to go for second part. In the second part, we have to control the brightness of the LED. Now, in order to do that, we will be using PWM function that we have studied in detail in our theory course. Now, you see, for that, we have to use one of the pins, that is PWM enabled pin. Okay, so that you can have an PWM output. Now, you already know that not all the digital pins of Arduino is provided with this facility. Pin number 9 is one of the digital pins that is provided with PWM output facility, and therefore we will be using Arduino pin number 9, and therefore there is no need to make any hardware change in this circuit. The circuit will remain altogether the same, only we will be using a different sketch. Now let us go for the sketch. Now you can see here, this is the sketch. This in the very first line we have declared the LED pin. You can see I have deliberately changed the name just in order to show you that LED pin is not to be required. It is not a compulsory statement. You can write LED or you can write your name also here. But the same thing you have to use throughout the program whenever it is required. So here you have given the name LED, that is given to pin number 9. Now you see this setup part in which we have given pin mode, right? This pin mode, this function has been used. This LED pin we have used as output pin. All right. Next, let us come to the void loop. Now this is an important part, while it will be continuously cycling during the execution of the program. Now you see here we have used the for statement here. Now within this for statement, this bracket, you can see there are two statements and one condition. This is statement 1 on the left side, statement 2 on the right side, and in between there is the conditional statement. So we have declared one integer I. The initial value of I is 0, and we have asked this I to increment by 1. Now whenever this program will be executed, the I will start incrementing from the value 0. Now till what value it will get incremented? We have asked it to get incremented till 255. Alright, so once it is equal to 255, it will stop the increment operation anymore. Now you can see the value of I is written to pin number 9 through the analog write function. Now I am not detailing the things here because we have already carried out all these discussions in our theory part. So you just go back to your theory part and you try to confirm what you have understood here. So that will be a good exercise for you also. So we are writing this value of I to the analog write through the analog write function to analog this LED pin. Now you see here this LED pin does not be written with 0 or 255, that we know very well. It will be written with some proportional voltage value. Alright, and finally there will be a delay of 45 milliseconds so that we can see the fading operation clearly. Now you see, once the LED has fully glown, the next part is to fade the LED. So here, once the LED has been fully glown, it is at its maximum brightness, the value of I is 255. Now I am to decrement I by 1. So you can see here there are two statements and in between there is the conditional statement. So initial value of I is 255. It will be decreasing by 1. Okay, in step of 1. Now you see till what level it will decrement unless it is equal to 0. If it is greater than 0, it will keep on decrementing, and once it is equal to 0, it will again start incrementing. You can see this for statement. Now this is the application of for statement that we have discussed in our theory section. Now you can see this analog write function. This analog write function again we have used to write the value of I to the LED pin. Again we have given a delay in order to see the effect of fading. So we will verify this sketch, verify the code rather. We will upload, and now we will see what is happening. Let us have a look to the brightness of the LED. Slowly it is getting brighter. At one point it will be coming at maximum brightness, and you can see immediately it will start fading. Now you can see the LED is fading. Again it has started brightening up. So this constitute the second part of experiment 2. Now we will be going for the final part, that is part 3. You can see in part 3 our main objective is to on or off the LED using a momentary push button. But in the code I have made a certain change. What I have done? I have done the coding in such a manner that if you press the button, then the LED will blink. If you release the button, the blinking will be stopped and the LED will be off. So in case of that blinking, if you only keep it high, that is the output state to be high, the LED will remain on. Just to see a multivariation of the program, we have done that. We will see during operation. Now, as I have told you earlier that in during while performing this experiment, I couldn't find a momentary push button switch. So I have used this switch. This is a push to on switch. In a momentary push button switch, what happens? When you press, it is connected. When you release, it is no more connected. That means the terminals. When you press, the terminals get connected, the switching terminals. When you release, they are disconnected. But this is not the case with this switch. When you push it, it remains in that condition. When you release, it gets released. Like that. Now, another thing that you have to remember that these are the terminals, 3 terminals of the switch. 3 terminals. The center terminal is the common terminal. One terminal has to be connected to ground and other terminal has to be connected to 5 volt. Okay. This center terminal will be given to one pin of the Arduino board that will be reading the state of the center pin. While connecting the switch, be very sure that you are not making a short. So here you can see I have connected the switch, and since it is across 3 vertical lines, it is ensured that it is not shorted. Okay, now if I had connected the switch like this, you can see I am connecting the switch like this. This means that we are nothing but shorting terminals. Okay, now I'll be connecting the switch like this. All right. Oh. So you can see the switch is connected. It's got some, because of the terminals, spring effect is there. Now the switch is connected. All right. I have removed the LED so that it does not distract our concentration. Now we need some additional connections to be made. Let us do that. First of all, let us look into the code, because the code will help us. You can see the LED pin is connected to pin number 8 right now. The button pin, that is the switch pin, is connected to pin number 7. So here we have to connect the center terminal of the switch, which is the common terminal, to pin number 7 of Arduino. Let us do that. So you can see I will be using this jumper for the common terminal. You can see I have connected to the common terminal. This common terminal has to be connected to pin number 7. So this is pin number 7. I have connected it. Okay. One of the terminals I have connected to 5 volt directly. So I will be using another jumper. This is the 5 volt terminal. I have connected it to 5 volt. Okay. And I will be directly putting it to another terminal of the switch, one of the stroke terminals. And then finally I am to connect it to ground through a 10 kilo ohm resistance. So here is the resistance that I will connect here. Again, I couldn't find a 10 kilo ohm resistance, so I am using a 4.7K. So you can see that how we can connect. We have to make some arrangements. That's what I have done. So you can see here we have this resistance is connected here, one terminal of the switch, and this terminal we will be connecting to ground. So I'll be using another ground. One of the ground is gone to the cathode of the LED. Now you see we have to make a change, because earlier our LED was connected to pin number 9. I will just connect it to pin number 8. You can also use pin number 9 definitely. As per the coding, I am to make this change. So it's all ready. Now again I will be connecting the LED. Alright. So now you can see our circuit is ready. We have used this switch, which has got a common terminal and 2 throw terminals. One of the throw terminal is connected to 5 volt. Another throw terminal is connected to ground through 4.7K resistance. The common terminal of the switch is connected to pin number 7 of Arduino, and the LED is connected to pin number 8 of Arduino through a current limiting resistor, that is a value of 330 ohm, and cathode of the resistor is cathode of the LED is directly connected to ground. So this is all about the circuit. I'll ensure once. Yeah, circuit is right now completed. All right. So now let us go to the sketch. This is the sketch for button. You can see here We have named the pin that is connected to LED pin, which is pin number 8. Next, the pin to which the common terminal of the switch is connected, that is button pin, that is pin number 7. And we have also declared that initially the button state is low. Okay, then let us go for the void setup. Alright, here the serial begins at 9600. Why I have used the serial begin? That we can also monitor the switch status in the serial monitor. Then pin mode, that declaration for the pin condition. This is the pin mode function we have used. LED pin to be as output pin and button pin to be as input pin. So this is all about the setup part, and let us go to the loop part, in which initially we have declared one variable. This variable is button state. Now button state is decided by the condition of the button pin. Therefore, we have written the function digital read. We have used the function digital read. So digital read, which pin has to be read? The button pin. That is pin number 7. Now one if statement have been used. If the button state is high. Now remember here 2 is equals to signs has been given. 2 is equal to sign has been given. This you should be very careful. If you give here 1 is equal to sign, that will be a grievous mistake. We have already declared, discussed in our theory coursework. So here you have to use 2 is equal to signs. Okay. Now here you can find that digital write is there. So if the state is high, then we have simply used the blinking part of the code. Digital write LED pin high, it will remain high for 1 second. Then digital write LED pin low, it will remain low for another 1 second. So this is all about that. If the pin is not maintaining a high state, that means if the button state is low, then the blinking will not take place. Let us verify the code. Let us upload it, and let us see what is happening. You can see that initial state of the pin is low, so the LED is not blinking. Now I have pressed it. You can see the LED starts blinking. I can release the button, and you can see the LED has stopped blinking. So this is all about the part of demonstration with experiment number 2. In this case also, I will give you one assignment, that you do not blink the LED. Maybe you would like to just put it on or off. Please develop such program that will help you to have good exercise with this Arduino programming. That's all for now. Thank you.